Hey y'all, in this lesson, I'm going to teach you how to simplify radicals. Specifically, we're going to focus on square roots so that you can have help with simplifying in the quadratic formula. So there's two really popular ways I've seen, and I teach to simplify radicals or square roots in this case. You can use perfect squares or prime factorization. Now, if the radical has an index of like a 3 or a 4 or whatever, you would use perfect cubes or perfect, keep going. But we're going to focus on square roots, so we're going to use perfect squares. And some not common, but commonly used perfect squares. I have a table here from 1 to 12, because generally speaking, you're going to be pretty safe with using 1 to 12. Obviously, it goes on forever and ever and ever, but mostly for these types of problems, 1 to 12 is good. So the perfect squares, what that means is you take the number and you multiply it by itself. So 1 squared means 1 times 1, which is 1. 2 times 2, which is 4, and so on. So you fill out this table and we have perfect squares that we want to familiarize ourselves with and just get used to using. These are very commonly used, like I said before. So if you don't already know them, you might try to get familiar with them because you're going to be seeing them. And then the other method is prime factorization. And prime factorization just means that you take a number and you break it down into its prime factors. Prime means it is not, the number is only divisible by 1 in itself. So examples would be 2, 3, 5, 7, 11, and so on. And then I have an example here. We're going to do 75. We're going to break it down into its prime factors. You can start with whatever pair comes to your mind first. For me, it's 3 and 25. 3 is prime, so I'm done there. But 25 is not prime, so I'm going to keep going. 5 times 5. 5's prime, so I'm going to stop there. And the prime factorization is 3 times 5 times 5, or 3 times 5 squared. And that's all. So this isn't simplifying radicals, but I am leading into that. And I'm just trying to show you some background information that you're definitely going to need to help you with this lesson. I have a couple of properties down here. If you have my notes, then I added a definition because we're going to need it. The first property is if you have the square root of a component times a component, you can break it up into the square root of A times the square root of B, or whatever that component is, depending. And then the definition of a square root is the square root of A squared, so something squared, is A. And in words, what that means is the square root of A squared is one of the two equal factors. So if I were to look up here and go backwards with my table, the square root of 4 is one of the two equal factors. So the square root of 4 is 2, because 2 times 2 is 4. The square root of 9 is 3, because 3 times 3 is 9, and so on. So I just kind of depends. I was going to say I use this method more often for simplifying square roots. But if the number's like really, really big, I might use this. So it just kind of depends. But basically, you're going to use the method of your choice. I'm going to show you both. And then when you're working on your own stuff, you can pick whatever works for you. And that's perfectly fine. That's how math is. All right, so square root of 16, we know that 16 is 4 times 4. And by definition, we use one of the two equal factors. So the square root of 16 is just 4. If you wanted to, you could use the prime factorization. This one was a perfect square, so it's kind of simple. But if you wanted to do prime factorization, you could do 4 times 4 or 8 times 2, just to show you that it doesn't matter which pairs you pick to do your prime factorization. You're still going to end up with 2 to the 4th. 2 times 2 times 2 times 2. And then how I do it with the factor tree is if I have this under the square root, you're looking for pairs, because in the pairs, you can pull out one of the two equal factors. And we still get 4. So a little messier that way, but it does work. So square root 4, again, if we look up at our table, 4 is a perfect square. It is 2 times 2, and one of the two equal factors is just 2. So square root 4 is 2. And then same thing with prime factorization, 4 breaks up into 2 times 2. One of the two equal factors is 2. It's perfect squares, and okay. Now try square root of 100. If you're not sure, you can check your table, see if 100 is a perfect square, and it is. Its square root would be 10. Or you can do prime factorization, look for your pairs, pull out one at a time. And we know this is 10. So that one's pretty fast. So really what you're here for, those were really easy. Really what you're here for today is where we have the square root of a number that is not a perfect square. So if we go up and we look at our table and we're like 50, okay, let's look at our table. 50, where are you? Oh, so close. So here's 49, but that's not 50. So that doesn't really help us. And then the next one is 64. So we do know it's going to be somewhere in between 7 and 8 if I were to put it in decimal form. But the purpose of this lesson is the problem isn't asking for decimal. It's asking for an exact solution or an exact answer. And in that case, that means you're going to have a square root in your solution. They don't want decimals. To do decimal, you just type it in your calculator and you're done. Super easy. If it were a decimal, it would be between 7 and 8. So this is where the two methods come in handy. I know that 50, if you look at the table of perfect squares, 50 is divisible by 25. And then I can use my property where I split those up. And the square root of 25, that is a perfect square. That's 5. And my answer is 5 root 2. That's done. And I know it's done because 2 is prime, so I can't go any further. Or even if it's not prime, if it doesn't break up into perfect squares, then you're still done. So that would be your solution. And let me show you a quick hack. If you're unsure about whether you got the right solution, type in second x squared 50, 7.07. Now type in 5 square root 2. I got the same answer, so I know that those two numbers are equal. Square root 50 is equal to 5 root 2. Now, if you were going to do the factor tree instead, then you would have 50. You can break it up into 2 times 25, 5 times 5. So I've got my primes. That's 2 times 5 times 5. We have a pair here. So 1 gets to come out. The 2 does not have a pair. So it does not get to come out. And that's it. You're done. So 2 different ways to do the same problem. We got the same solution. You get to pick which one you like the best. So for square root 128, go ahead and try it. You can use the method of your choice. I'll show both, but go ahead and try it. This one ended up being pretty cool because there's several different ways you could approach this. And you can see I left my calculator up on the left so you can kind of see my thought process, hopefully. If you're using perfect squares, basically if you're not sure, if you're like, I don't know what 128 is divisible by, just start. I started with the smallest number. If I could give you a recommendation, I would say, or a hint, I would say start at the larger end. Because when I divided it by 4, it was divisible by 4, but 32 has a disguised perfect square in it. So I was just curious and I tried 16 and I saw, oh, 8. Okay. Oh, well, 8 has a perfect square in it. It's 4. So I went a little bit bigger. 36, it wasn't divisible by 36. So I went a little bit bigger to 64. and I found that 64 was divisible by it, or I'm sorry, 128 was divisible by 64, and its other factor was 2, which is prime. So basically what you're trying to do here, I hope that wasn't confusing. What you're trying to do here is you're trying to find the largest perfect square that 128 is divisible by. So that's why I would recommend starting at the larger end, which is not what I did. But if I were you, I would do that. So start at 100 and it's not divisible by 100, then go 81 and then 64, and you would have seen, oh, it is divisible by 64. So don't do what I did. Don't start small, start big and work your way down so that you can find that largest perfect square that it is divisible by. If you didn't and you still got the same answer, then that's perfectly fine. As long as you got 8 root 2, you're good. And then prime factorization, this one was kind of my tree got kind of messy, but you end up with basically 2 to the 7th, but I went ahead and I wrote it all out, expanded, and I got, 2 to the 7th is 2 times 2 times 2 times 2 times 2 times 2 times 2, so many twos. And we have pairs here, and one of the two equal pairs gets to come out. So 3 twos get to come out, but I be very careful because you might go 2, 4, 6. But that's not what it is. We're not adding, we're multiplying. 2 times 2 is 4, times 2 is 8. So we still get 8 root 2. So lots of areas where you could trip up on this one. That's why I wanted to put it on there, but that's how you would do that one. So let's try this last one up here, square root 98, pause it, try it, come back. Again, if you're using the perfect square method, start at the larger end, not the smaller end. So for this one, I knew that 98 wasn't divisible by 81, but I just wanted to show this in case you're not good with that. Just start at the one closest to it and start dividing. This table up here, I started at 81 and then I just worked my way down, and that's perfectly fine. If you're not sure, if it doesn't come right to you, you don't have to worry about that. Just use your table and start working your way down. And I found that it was divisible by 49 times 2, and the square root of 49 is 7, and then the 2 stays under. Or if you do a factor tree, you get 49 times 2, 49 is 7 times 7. That's your pair. One of them gets to come out, and we get 7 root 2. So that is simplifying radicals. I have a couple examples down here since I promised that this relates to the quadratic formula. This would be an example of once you simplify your quadratic formula, maybe it looks like this. And it's saying it wants your solution in a completely simplified form, no decimals. Then square root 50, 50 is not prime. So it's not completely simplified. Now we already simplified square root 50 in a previous example, so that's going to save me some time. And I'm going to skip right to that. 2 plus or minus, that was 25 times 2, so that was 5 square root 2 over 4. And that's one way you can write it. If it does reduce, you should reduce it. But we have a 2, a 5, and a 4, and they don't all have a common factor except 1. So you would finish there. I have seen some homeworks and books that break this up into 2 fractions. 2 over 4 plus or minus 5 square root 2 over 4. They both have that common denominator of 4. And 2 over 4 does reduce. So I've seen that. It is not as common, but I have seen it. So it may ask you to do that, which is fine. So we have 2 solutions here. Whoops, 2 solutions here. 1/2 plus 5 root 2 over 4 and 1/2 minus 5 root 2 over 4. So that's how you would simplify that. So I want you to go ahead and try this one. Pause it, try it, come back. Hopefully you got 3 root 2 as the simplified version of square root 18. I used perfect squares because it's a pretty small number, and that's 9 times 2. Square root of 9 is 3, and then 2 stays under. So I have 3 plus or minus 3 root 2 over 3. Now this isn't completely simplified because these numbers outside are all divisible by 3. So you can do that. You can divide them all by 3 like that, kind of messy. And we get 1 plus or minus 1 root 2. You don't have to write the 1 over 1, which is just 1 plus or minus square root 2. Nice and neat. Or you can break it up into 2 fractions like I did before, like this. And then simplify. 3 over 3 is just 1. 3 over 3 is just 1. And we get the same answer. So either way is okay. I feel like this one's a little cleaner and is going to prevent some mistakes. Like if this had been a 6 or a 7 or something, maybe you would get confused and a little unorganized. So just be careful with that. If breaking it up is more organized for you, then go ahead and do it that way. But we have 2 solutions, 1 minus square root 2, 1 plus square root 2, and that's it. That's completely simplified. Okay, last one. Pause it, try it, come back. This one's a little easier. Square root of 0 is just 0. So 4 plus or minus 0 is just 4. And we have 4 over 2, which is 2. So this one would have one solution if it is a quadratic. For a quadratic with one solution, that just means it touches down at the x-axis at 2 or up at the x-axis at 2. So that's kind of what that would look like. I have some different, those are kind of the same, but 2 different scenarios there where the 0 goes away kind of and you just get one solution, and then the other 2 were where you have 2 solutions. And in the future lessons, we will have a third scenario where we simplify radicals with imaginary numbers. But that is all I have for this lesson, so I'm going to stop here. I hope you enjoyed it. If you have any questions, let me know. I'd be happy to help, and I'll see you in the next one.